All right, so in Algebra 2, the next thing that we're going to do is Lesson 2.2. This is the next video. You should have watched Lesson 2.1, and before even Lesson 2.1, you should have made sure that you've done the Chapter 1 review homework as well as taken the Chapter 1 test. So if you haven't done that, stop this video, make sure you go finish everything for Chapter 1 as well as look over everything for chapter and lesson 2.1. Okay, so now for lesson 2.2, we're going to be talking about adding and subtracting rational numbers. Now let's go back for a second. You might not remember what rational means, but if you just watch the most recent video, rational is just a fancy way of saying anything that can be a decimal. Okay. Now, some examples of this are, remember, there are whole numbers, there's natural numbers, and that's supposed to say fraction, excuse me, a decimal, a fraction. All of these things that can be classified as a decimal or a fraction is what we call a rational number, okay? And what we're just going to be doing for this lesson is just adding and subtracting them. And to be exact, all we're really doing is just adding fractions, subtracting fractions, and in a bit we're going to be adding and subtracting decimals. So this is stuff that you should have done back in fundamentals of math and pre-algebra. So this is kind of more of a review, especially for you Algebra 1 students, okay? So let's start off with example number 1, because example number 1 on page 52 to me is the easiest one. Anytime we add or subtract, the rule for all 4 of these, okay, is to make sure that we have what's called common denominators. So everything here, we need to have common or alike denominators. What do I mean by that? That means that the bottom number needs to be the same before I go and add it. Now, in the case of example 1, I already have the denominator set up as 7. So my denominator for my final answer is going to be 7. Okay, but now I can just add my numerator, 3 plus 2, which is 5, and that's my final answer. Okay, obviously example 1's easy. Let's get to example 2, because example 2 now does not have common denominators. So there are so many ways to go about getting the common denominator. I'm going to show you 2 ways, and you can kind of choose which way you rather do. Okay, so I'm going to show the work up here. I'm going to do method 1 and method 2, okay? And I'm going to start off with method 1. Method 1 is to find what we call the least common multiple, right? And we talked about multiple last class. And the way that we find a multiple, okay, is basically by breaking this down as a factor tree. So 4 and 3, right? So I have to break it down to its prime numbers, and in this case, 2 and 2, and 3 is already prime, so I can't really break this up anymore. Now, what I do from here to get my least common multiple is I need to make sure that I multiply the highest, remember, the highest exponential or exponent value of each number. So here I have 2 squared, here I have 3. In other words, all I'm doing is 4 times 3, which is just 12. And that is my least common multiple. That's the denominator that I'm going to change this to. In other words, instead of writing 4 and 3, I'm going to rewrite these fractions with a new denominator of 12. Now that was method 1. Method 2, some of you might prefer because it does go by a bit quicker. You're still finding the least common multiple. This time you're just listing out the multiples of 3 and 4. So the multiples of 3 are 3, 6, 9, 12, 15, so on and so forth. And the multiples of 4 are 4, 8, 12, 16, so on and so forth. I find the smallest value that are alike, and in this case it's 12, and that's my least common multiple. That's the denominator I can use. However, because I changed the denominators for both of these, I now need to change the numerators. And how do I get from a 4 to a 12? Well, 4 times 3 gets me 12. And whatever I do to the bottom, because I did times 3 here, I'm going to have to do times 3 to the top of this. And 3 times 3 is 9. And now I do times 4 here, right? 3 times 4 is 12. So I got to do 2 times 4, which is 8. And when I can finally add them up, because they have common denominators, the denominator stays the same, and I do 9 plus 8, which is 17, and that is my final answer. Now for example 3, I'm going to go by a bit faster. You can use method 1 or method 2. Just for time's sake, I am going to use method 2, okay? And the least common multiple for these, I already know, is 28. And that's because I have 28 times 1 is 28. 28 times 2 is 56. Those are pretty big numbers. And 7, I have 7, 14, 21, 28. So right there, I already know that is my least common multiple. So how do I get from a 7 to a 28? Well, 7 times 4 is 28. And if I did times 4 here, I have to do times 4 here. And 3 times 4 is 12. The good news is, if 28 has the same denominator, 5 is going to be the same numerator. And now I'm going to subtract these. And here I get 7 over 28, which is basically my final answer. However, if you read the directions, it's just going to say subtract. Sometimes in more specific directions, it's going to say to simplify this, meaning I have to find a number that can go into 7 and 28. And the only number that I know that I can simplify is by dividing everything by 7. Here's what I mean. If I do 7 divided by 7, what's my new numerator now? 1. And if I did 28 divided by 7, what's my new numerator now? 4. So this is the correct answer. This is also the correct answer, but I would always prefer it simplified. So this is the most preferred. Now I'm on my very last one, and again, I need to get the least common multiple for 32 and 8. And let's list out the 8's multiples. I have 8 times 1 is 8, so 8 and 16, 24, 32. Hey, that's already looking like this one, so I'm going to keep that as my denominator, okay? So if you notice, some of these problems are pretty repetitive. Just instead of adding, maybe you're subtracting, but same concept here. 32 is the denominator here, and those are the same, so I keep my numerator the same. Okay, now 8 times what gets me 32? 8 times 4, and what I do to the bottom, I do to the top, and now I do 5 minus 4, which is 20. Now this problem is going to be extra special because my denominator does stay the same as 32, but now what do you notice about when I subtract? If I had 3 fingers, can I take away 20 from here? No, meaning that this is probably going to be a negative number, okay? Now, if you know how to solve it mentally in your head, that's one way of doing it. Another way of doing it is writing it off to the side and seeing if that helps you. If you notice, there's a subtraction sign, so I could do keep, change, opposite. And here's what it really is going to look like. It's going to look like 3 plus negative 20. They have different signs, meaning I'm subtracting. So when I subtract 20 and 3, I get 7. And I take the sign of the bigger number, which is negative. And this is my final answer. So all that we have done for examples 1 through 4 on page 52 and 53 is just add and subtract one form of rational number, in this case, all the fractions. Now, if you go to examples 5 and 6, okay, this is going to be on page 54. This is kind of towards the end of where we're at. So example 5 and 6, right? And this is on page 54. Example 5 says they want you to add 2.39 plus 14.682. And then in example 6, they're going to want you to subtract okay, on the same page, they're going to want you to subtract 39.27 minus 112.6, all right? So here I go. I'm going to add and subtract these decimals, which is another type of form of what is a rational number. Remember, rationals can be fractions. They could also be decimals. They could be whole numbers or natural numbers, integers, whatever it is. This is one way of adding and subtracting rational numbers. So here's one of the main things I need to emphasize with all this, and I'm going to have to put it over here. When I add or subtract decimals, and we'll call this a key rule. So if you need to write this out, I recommend you do. One of the key rules is when you add or subtract decimals, okay, make sure the decimals are lined up. So again, if you're adding or subtracting decimals, make sure your decimals are lined up. So for example, here I have 2.39, and I'm going to add it with 14.682. Again, making sure that my decimals are on top of each other. I can now add it, and if you really like to, if you notice that there's any blanks, what number represents nothing? That's right, 0 represents nothing. So you can fill those in with zeros, and it makes it a lot easier to add, because 0 plus 2 is 2, 9 plus 8 is 17, 1 plus 3 is 4, plus 6 more is 10, 1 plus 2 is 3, plus 4 more is 7, and 0 plus 1 is 1. Now, what do I do with my decimal? Because it's lined up, they're all kind of staying within that area. I just need to put my decimal here, and that is my final answer, 17.072. Okay? Now, I am going to do the same thing with subtraction. You are going to notice something fishy about this one, though. And one of the things that you're going to notice is when I start setting it up, take a look. We want to make sure that we line it up, 39.27 minus 112.6. You're going to notice that the top number is smaller than the bottom number. That's right. That means this answer is most likely negative. Okay? So what should I do in this case? Well, maybe you should do keep, change the minus to a positive, and change the positive 112 to a negative 112.6. From here, because you know they have opposite signs, you're going to subtract like normal. This time, we're just going to write it as 112.6 minus 39.27. Still, though, lining up the decimal. Any blanks that you see, you can fill them in with zeros and subtract like normal. Let's get ready to do 0 minus 7. 0 minus 7, you got to borrow. The 6 becomes a 5. The 0 becomes a 10. 10 minus 7 is 3. 5 minus 2 is 3. 2 minus 9, can't do, so I got to borrow from the 1. That 1 is going to become a 0. The 2 is now going to become a 12. Now I can do 12 minus 9, which is 3. Can I do 0 minus 3? Nope. Got to borrow from the 1. This becomes a 0. This 0 becomes a 10. And 10 minus 3 is 7. Obviously, 0 minus 0 is 0. I line up the decimal. And I know that my answer is 73.33. However, because we did keep change opposite, and we notice that the bigger number is negative, my answer is going to be negative. Okay? So we do need to pay attention when we add or subtract. Make sure that if you notice, specifically for subtraction, that the smaller number is coming first. Make sure you just kind of switch these around and that your answer will maybe most probably be negative. All right? So the whole point of lesson 2.2 was adding different types of rational numbers. One type was decimals, and the other type was fractions.